This is a demonstration of my LoRa-based mailbox sensor using actual junk mail. You input mail into the mailbox and the indicator indicates there's mail in the mailbox. You remove the mail and the mailbox indicator goes down. Now if you want the mailman to pick up mail, you flip your flag up. You don't want the indicator to show there's mail in the mailbox, and it doesn't. Go back, flip my flag down, and the flag goes back up. The sensor is triggered every time the door closes. This is the inside of the mailbox, instrumented with the various sensors. This sensor right here is the mercury switch, which generates a falling edge when the door closes, and the microcontroller triggers the interrupt on that, and it triggers the actual sensing phase of the operation. Over here is the sensor to detect the position of the flag. It's actually a rotational sensor, which is really just a kind of conveniently form-factored pot, which is then hooked up to the ADC, so the actual position of the flag can be measured and read by the microcontroller. The actual mail sensing is occurring through an IR proximity sensor that's taped to the top here, and it's this right, it looks just like this right here. On this custom-made PCB is the VCNL 4200 proximity sensor. It's a IR transmitter and receiver, the two little dots on each side. This thing modulates the IR signal and then measures the receiving intensity of the IR reflected back, and returns that value to the microcontroller through I2C. This works pretty well in this application because the empty mailbox itself is pretty much of a poor reflector of IR, but when mail is inserted, the IR signal reflected back is quite strong. So the values that the device returns to the microcontroller are quite obviously different and easy to tell that there's mail inside the mailbox. The big downside of this device is it's a dual power supply. The IR LED itself is run off of a 5-volt supply, and the circuitry itself is run off a 3.3 volt power supply, which is going to complicate the design of the power of this device. This is the breadboard of the microcontrollers, which runs the sensors. The microcontroller is an STM32L0 class device, a low power device with only 16K of flash, which is not enough to hold the driver code for the SX1276 modules normally used for LoRa communication. In this case, I use this E32 LoRa module, which is a UART serial device with a simple interface that doesn't tax the resources of the microcontroller. The rotational sensor is connected down here to the ADCs, and the mercury switch is connected to an interrupt GPI through this low-pass filter here to filter out some of the bounciness of the signal. The mail flag indicator is simply a 3D printed case around an ESP32 module with the same LoRa module here and a servo that is connected there to move the flag up and down. The ESP32 base station also connects to an MQTT server running on a Raspberry Pi. This Pi closes my garage door if I leave it open and blinks LEDs, but it also collects data from sensors, logs status messages, and text error messages to me, which are the facilities I'm leveraging for this project. The base station publishes the mail proximity sensor value, the flag position's ADC value, the battery voltage, and the temperature. Listening on the MQTT topic is a Python process which will pick up these messages and then log it to a service called Loggly, which is similar to Splunk or an Elk Stack. These logs can be searched and extracted so I can get an idea of what these values look like over time and tune the right values for these things like the proximity sensors to know when the right values are set. The temperature and battery data will also be sent to a website called ThingSpeak. While I haven't been collecting data yet for this particular project. This is the data being collected from my garage door server, showing the temperature, the humidity, the CPU temperature, and the light level values over time. More information about this project, including links to schematics, code, discussions of the various sensors in more detail, can be found on my Hackaday.io project page, linked in the description below. Thank you.